Spring force. We see spring in our day-to-day life. If we push it, then it pushes us back. If we pull it, then it pulls us back. In fact, a spring exerts a force on the object that is attached to it in order to restore its shape. If no forces are applied on the spring, then it is in its relaxed state. Length of the spring during relaxed state is called natural length of the spring. In case of ideal spring restoring, force is directly proportional to the deformation length. Here, boy pulled a spring by a distance x and natural length of the spring is L0. As the spring is elongated by a length x, therefore, an inward restoring will act. This force will be proportional to the elongated length. Hence, restoring force is equal to K into x, where K is proportionally constant. We also call K as a spring constant. If the boy pushes the spring in inward direction, then a spring is compressed. Then again a spring will apply a restoring force in outward direction. Let compression length is x again. Then restoring force is equal to kx and it is pointing outward. So, restoring force will always equal to kx. This relationship is known as Hooke's law. Example. In the arrangement shown in figure, if acceleration of 15 kg block at a particular instant is 2 meter per second square, find acceleration of 10 kg block at this instant. Solution. If 60 Newton force is applied on 15 kg block directly, then we can obtain its acceleration by using the relation A is equal to F upon m. That is 60 by 15. Hence, acceleration is 4 meter per second square. But as per the question, 15 kg mass has an acceleration 2 meter per second square, not 4 meter per second square. It is because of the spring which is applying an opposite restoring force on the block. On the block of 15 kg, a spring is applying an inward force equal to kx in inward direction. So, we can write its equation of motion for 15 kg block as 60 minus kx is equal to 15 into 2. As net force is equal to mass into acceleration, therefore, kx is equal to 60 minus 30. That is, kx is equal to 30 Newton. Let us apply equation of motion for 10 kg block. Here, kx is equal to m into a. We have already derived the value of kx using equation of motion on 15 kg block. Hence, we get 30 is equal to 10a. Therefore, a is equal to 30 upon 10. That is 3 meter per second square. Example. In the system shown here, all the surfaces are smooth. If the system is set in motion under gravity, find the extension in a spring under the state of uniform acceleration of block. Solution. Block of mass 30 kg has a weight of 30 g. So, it will experience a tension in upward direction. As a result of this, there would be elongation in the spring. Suppose elongation is x Then we can say that tension is equal to Kx because tension is applying a force T in upward direction and it is pulling a spring with an inward restoring force, that is Kx. Therefore, it has to be equal to Kx. Here, under the action of uniform acceleration, block of 30 kg is coming down with acceleration a and block of 40 kg is also moving with the same acceleration. So, we can write the equation of motion for these blocks. For 30 kg block, we can write as 30g minus t is equal to 30a, and for 40 kg block, equation is t is equal to 40a. After equating these equations, we get 30g is equal to 70a. Therefore, a is equal to 3 by 7g. Hence, tension is 120 by 7g. So, we get tension equals to 1200 by 7 Newton. And we know that tension is equal to Kx. Hence, Kx is equal to 1200 by 7. Putting the value of K, we get 2400 x is equal to 1200 by 7. Therefore, x is equal to 1 by 14 meter.